Okay, so CS150, today I want to talk about enumeration types, and this is part of Lake's Chapter 7, which is kind of the miscellaneous catch-all section of CS150, and it's kind of thrown in a hodgepodge manner. Pages 487 to or 478 to 487 has an example that shows how to do rock, paper, scissors with enumerated types. And it's not a bad program to enter if you'd like to create a program that takes advantage of these enumerated types and shows you some of the power of them for making clear code. So the first thing in chapter 7, as I mentioned, is these enumerated types. And so a data type, such as int or double, is a set of values along with a set of operations associated with them. For example, a set of values or a data type in C++ could be int, double, char, and then there would be different operations that can be associated with each one of those. An enumeration type is a simple data type that's created by the programmer. And to define this, you need a name for the data type, a set of values, and a set of operations. You only need to specify the first two for yours. And they technically correspond to the natural numbers. The enumeration type is an ordered set of values, and they start at 0. A value used in one enumeration type cannot be used by another in the same block, and the same rules apply to enumeration types declared outside of any blocks. So here's an example of an enumerated type. Here we have class standing. So you start as a freshman, become a sophomore, a junior, and a senior. And so standing is an enumeration type. The values belonging to standing are freshman, sophomore, junior, and senior. And so you can declare variables such as Mike standing, which is a type of standing from that enumerated type, and then set it equal to sophomore to denote that Mike is a sophomore. When no values are explicitly specified, the enumerators are assigned consecutive values starting at 0. So freshman is 0, sophomore is 1, junior is 2, and senior is 3. If you don't give a name to an enumeration type, it becomes an anonymous type, but you probably want to avoid doing that for 150. So if Mike standing is equal to senior, you could say almost done. Otherwise, you could say, well, you've got a long way to go in your studies. You could also use the switch statement on the enumerated type. So you could switch based on Mike standing. Freshman, sophomore, junior, you could say you've got a long ways to go, and then do the break, and then case senior, you're almost done. And then default case, that doesn't seem like a valid class standing. You can't do arithmetic operations on enumerated types unless you use static cast. So here we have a popular sport called football, and that's one of the values in the enumerated type. And we could do the next popular sport by static casting to sports, popular sport +1. And basically you can use the preceding trick to make a loop with all of them, but it's probably not the best thing to be doing. You can also pass them to functions, and you can make comparisons on them. You can't input and output them directly, but you can use a switch statement to achieve that. So here I have courses for maybe a CS degree, algebra, basic, Python, C++, philosophy, analysis, chemistry, and history. And then I can indicate the registered courses, switch on a particular value, char 1, and then have char 2. If char 2 is L, then it's algebra. Otherwise, it would be analysis, because I have two things that there. So I can do take in two different values. This is a technique that you'll use in fairly limited circumstances, but compared to just using an int, it definitely makes the code more readable and more easy to modify. So you can see all the possible values of the enumerated set. And it gives an order to a named set. Some people are more fans of enumerated types than others. If it makes your code clear and readable, then I would say you definitely want to use it. Anyway, thanks so much for watching, and see you next time.